Oh, man. No, I think it's going to work out fine.
Okay. So put this away is what you're saying?
That's not what I was saying.
Oh.
Yeah.
Pretty.
That was like not what I was saying at all. I think we could do this box plot portion and then, yeah. We'll come back and we'll look at those other examples tomorrow, I think, is how that's going to work, okay? Do you guys know, have you heard of a box plot before? It might have been called a box and whisker plot. Yeah. Have you heard of a box and whisker plot before?
Partially.
It was on that test you done took, like the ACT? ACT, it was on the ACT?
Maybe not. One of the standard.
You definitely did them in like, I don't know, 6th or 7th grade?
I think they were just like
What?
the 2 extra variables that we didn't add.
Yeah, we probably should. I mean, yes and no, because we're using the 5-number summary that we already found. All right. So, guys, we said the min was 1.08. Q1 was like 2.875. 2 and some change. What was Q1? Can someone turn back and look for me?
2.745.
And then the median was 4.125? No. At this point, I'm confusing all my different data sets. I've got like 3.325. Q3 was 4.13. And then the max was 7. Cool. And then we had outliers at
6.75 and 7.
perfect. All right. Box plot is very similar to what we just drew when we drew in our dividing lines, okay? So to make a box plot, you're going to start with an axis. My lowest point on this is a 1. My highest point on this is a 7. So my axis is going to go from 1 to 7. Okay. My min. So a box plot has essentially 5 numbers to it. You have, this one's going to be your minimum. This line is going to be your Q1, your median, your Q3, and then your max. It is essentially a graph of that 5-number sum we just found. Okay? So what I'm going to do is make a point at 1.08 since that was my minimum. Then I'm going to do the 3 lines for the Q1, the median, and Q3. So 2.745, 3.3, 4.13. I can connect those. I'm going to make a point at 7, but I'm not connecting to that point. I'm going to make a point at 6.75, and I'm not going to connect to that point. I'm going to make a point at the 5.66 because that was the next highest point, and I'm only connecting to that point. In other words, we don't connect to outliers, but we still graph them. So I can look at this box plot right away and say, oh, there were 2 outliers that were really high, and then everything else looks pretty darn close to each other. Okay? I probably should put word crossword times there and so on and so forth. How are we doing, okay? Is it making sense? We'll practice this some more tomorrow. yesterday, we learned about 5-number summaries and stuff like that, right? Okay, so this was our 5-number summary. We drew a graph called the box plot. You guys remember doing this?
Yes.
Okay. We calculated something called the IQR to determine if they were outliers. We used that IQR to determine if they were outliers. That's how we knew these highest two numbers were, in fact, outliers. Okay? And the way we calculated it is we did 4.13 minus 2.745. And we got an answer. Yes?
Yeah.
I don't remember what it was. You get 5. So my question for you guys is, how can we see that 1.385 on the box plot itself?
Because you can see the third quartile is just after 4, and then if you were to add that 1.385, it's a little farther.
If you were to, okay, not the fact that it's outliers, but the IQR itself, it is this distance. It's the distance between those Q1s and Q3s. Are we comfortable with that idea? That to find the distance between two numbers, you subtract them. Okay. So the IQR is the length of the boxes. How can we see the range? The range is the distance between the minimum and the maximum. So in this case, it would be 7 minus 1.08, which is 6.92. And the way we see it is we look at the distance between the min and the max. That's my range. So before we do this last piece here, I want to here's what I'd like you to do, and I did this so that you guys can see it. I would like you to sketch the box plot of this particular set. we feeling good about where? The how? Go ahead.
I'm still a little confused on how to get the quartiles of, I understand dividing 13 by 2 to get 6.5.
Can I wash my hands in here? Or should I go to the bathroom?
You can now that I have paper towels.
Should I use that sink over there?
I'd prefer you didn't because it splashes a lot.
This one?
Yes, please. Do you guys think I can throw it to him without hitting Mia in the
You got
head?
this.
It's gonna completely unravel. It will not.
You got this.
I'm gonna hit some.
It's not going to hit Savina.
I know.
If it hits anybody, it'll be Mia or
Oh yeah.
Haley. See? You guys think it's going to be perfect spiral? You ready?
It's not.
Over a little bit. Hey.
You got this, Theo.
This is going to take a lot of core strength because I don't have my feet, right?
You can stand up.
No, don't stand up. It's fun. It's fun sitting up there and trying to.
Are you gonna shot put it?
It feels like that might actually be a better approach. You guys are paying attention and know to duck, right? Nice catch, Haley.
I didn't think I was gonna make it.
I thought for sure I could do it, and it turns out I'm just weak. If it was a frisbee, I could have landed it in the sink. Just
I don't trust the accuracy.
I'm more accurate with a frisbee than just about any other projectile.
Frisbee throwing is fun.
Indeed. Guys, we're already behind.
Is that we're going right
In my younger days, I was real good with a frisbee. Now I'm,
Shuriken.
huh?
What about shuriken?
I don't know what that is.
And ninja star?
I've never thrown a ninja star. Frisbees aren't designed to hurt people, whereas the ninja stars are, so.
I mean, you can.
But I don't want
What
to,
about
see.
Japan? Basically a metal frisbee.
Is anybody else done listening to Walter over there?
No, I think we should continue listening.
Phew.
Bless you.
Was it good? Was it mathy?
No.
Then it's not the cool kind of standard deviation.
Well, I think it was like someone probably said that phrase at some point in the book, and that's why it was called that.
I'm not doing very good on my scales here. That's real bad.
Do you need the paper towels back?
Nah, they should be by where people can use them. They were up here because I spilled coffee all over this countertop this morning.
You should throw the paper towels back.
I don't care. I didn't.
How's your day?
Amazing. It's like not asking for a better day. Best day ever.
That's good.
It's because you had FST class today, right?
No.
That's what I heard.
Yeah.
What if one of the suicide boys walked into this classroom? Could it be a better day?
Yeah.
That's good to hear. It's not just a good day. It's a great day. Cody, you made today a great day, not just a good day. Thank you.
Thank you, Cody.
It was nice to be here. Theo makes it a good day.
I tried.
That's good. That's all that matters.
I think mine's just brain dead.
Nah. Guys, it's way too early in the year for me to go brain dead. There will be at least one moment where you guys see me pounding my head against a wall, though.
Oh,
It happens about this time every day.
it will be triggered by Walter.
There's a lot of candidates here
Who?
to make me pound my head up against a wall.
Is there anyone that isn't a candidate?
It's you,
Cody, I think
I don't know.
you're the reason that teachers want
All right, guys, what is a mean?
A mean person, right? Mean.
The average, what does that mean? What does that mean?
The good, I don't know, like the most frequent number in your data.
Yeah. What is it?
The average?
How do you find the average?
You add everything up and divide it by that.
You add them all up and divide by however many you have. Yes? Does anybody want to guess at the average of this set? Looking at the dot plot. Here's a hint. It is not equal to the median. It could be equal to the median. What did you say it is?
3.4.
What's making you say 3.4?
I don't know, it just like felt right.
It just felt right?
Yeah. Like, I was looking at it and then it balanced it.
Ooh. Guys, don't you be giggling at Dylan, because Dylan just said one of my favorite things about people talking about the mean. Good job, Dylan.
Thank you.
Do you know which word I liked the most?
Balance.
Balance. I like the mean being what we call a balancing point. Yes, Cody.
Would the average be somewhere around 3.2?
Was that what you got when you found it? I don't know. I have not found the average of this group.
I just did your strategy of just taking all the dots divided by 2 and then counting up the points.
Oh, that would give me my median. It wouldn't give me my average, my mean. Yeah?
It's like 2.85.
Did you do it? Did anybody do this?
No, I did not. I know, it's just I haven't opened
I just haven't opened my calculator. Is that what we're saying?
it. Yeah,
It's hard, it's Friday.
it's Friday.
Friday.
I got it.
This is not going to go well. It's going to be a long year if that's where we are right now.
That's the average. Oh, no. What?
3.5.
Exactly?
Well, like it's 3.5457.
Are you guys cool if I call it 3.546? And just for fun, I'm going to sketch a line right where I think it is. What do you think? Is that okay? And as Dylan said, guys, I want you to imagine this dot plot is actually, folks, a group of kids sitting on a seesaw that are all the same weight. Okay? If I were to ask you, where would the fulcrum of that seesaw be? Do you guys know the word fulcrum? Using context clues, fulcrum is the point on which it tips. Okay? Imagine my pen is that fulcrum. Everybody good? And I'm just going to, if I put my pen right here, what's going to happen to the seesaw? I think that left side's going to go down, yes? What if I put it here?
Still gonna.
And here?
Still there.
And here?
It's gonna go to the.
It's going to go the other way, yeah?
Yeah.
So tell me to stop my pen at the place.
Stop. What place?
What place?
The fulcrum.
Stop.
The fulcrum, sorry.
Stop. Where do I place it such that?
Stop.
You guys don't know where I'm trying to get you to. What if I said, tell me where to place my pen so that it definitely falls over?
On the line.
So it definitely falls over.
Not on the line.
Not on the line. Tell me where to. So if I wanted it to stay nice and flat, I would put it where?
On the line.
Fulcrum.
The full line is
The pen is the fulcrum. Where should the fulcrum be such that?
purple. 3.546.
Yeah, right there.
Right there. So this is the mean being the balancing point. Yes? Are we comfortable with this?
Yes.
Well, what does it mean? Why? Why is that the balancing point?
Because it is.
Did you guys know that Mr. Peters and I could in fact sit on a seesaw and it would stay nice and even?
Yes.
What would need to happen?
Leverage.
It could be the same way.
Depending on where in the seesaw you would sit. should be.
I would have to sit way on the outside, right? And he would have to be like close to the fulcrum, right? And so that's because we don't weigh the same, right? Okay. So each of these values has something called a deviation. And here's how I know this. Not a single one of you did the crossword in 3.546 minutes. Now, some of you were darn close. Like this person is has a really small deviation. And this person has that deviation. And that deviation is a measure of distance from that purple line. And likewise, this one, and then this one. And all of these are different deviations. Not like deviation like deviant. Right. We just started rewatching Loki. And deviant, it's a variant though is what they call them.
We thought of Detroit Become Human.
Also Loki.
You don't know that one?
Huh?
Become Human.
Trip computer.
It's about androids and they deviate from the programming.
That's like this whole thing about like how society looks out against things that are different.
It's a bit of
This is the second time I've discussed this concept today, which is a little bit unnerving because the other one was a completely different context where someone was like, we were talking about the average height of people. And if I asked you guys to guess what is the average height of men, adult men.
5'6".
5'9".
5'11".
5'10".
Men is about 5'11". And then here's what happened. Someone said, well, there's no way that's true because I see a whole bunch of shorter people than that. And I see a whole bunch of taller people than that. And the thing is, what we tend to do is our brains are like programmed to see things that feel unusual to us. Right? We're programmed to see deviation. So what is standard deviation?
Title of a book.
The title of a book?
the average deviation.
The average of the deviations, sort of. And when we talk about what does it mean to be that fulcrum, that balancing point, okay? Everything, if I add up all the deviations on this side of the graph, and I add up all the deviations on this side of the graph, what do you think is going to happen?
They should be the same
On
number.
the standard deviation.
That does not find me the standard deviation. But in order for it to make this balanced, these ones, the total deviation on this side equals the total deviation on this side. Is this okay?
Yeah.
It doesn't feel that way, does it?
I don't know. I'm just thinking about how we've been using the word mean a lot, and it has different meanings.
Indeed.
Yeah.
Indeed.
Mean has meaning.
That is 100% true.
I just love grammar in math class.
I love everything in math class.
Even the students.
Definitely the students. The students are why I love math class. The math is also why I love the math classes.
Do you like the class?
So, anyway.
So deviation is the distance between
The point
the
and
the-
a point and the mean. Okay, so let's talk about that. The deviation of a point is the distance between the point and the mean. So, what mathematical operation gives us distance?
subtraction.
Subtraction. Okay. So to calculate the deviation for each point, what I do is I take the individual point, so we put that little subscript I because it's lots of different points. So it could be the first one, the second one, the third one. Okay. And I subtract the mean. Okay. So when we look at, say, this point right here, this point has a deviation that is roughly negative, 2.5. Give or take. It's roughly negative 2.5. Is it okay if that deviation is negative? What does that negative tell us?
It goes left or less.
It's smaller than the mean. And likewise, this deviation is positive 3.5. Because it's bigger than the mean. Does this make sense? So when we talk about the average of the deviations, if everything to the left is negative and everything to the right is positive, and I add them all together, what am I going to get? 0. So we don't just find the average deviation. That's not what the standard deviation is, though in your head you're allowed to think of it that way. Okay? But the average of all the deviations is always 0 because it's always going to, we calculate average by adding together and dividing. If they add to 0 and then I divide, I'm going to get 0. Okay? So the mean is the place where the deviations add to 0. Or the balancing point. And really when we call it the balancing point, like Dylan said, that balancing point is because the deviations add to 0. Now, I'm going to ask you guys to interpret the mean, just like we talked about how to interpret the 5-number summary and the range and the IQR. Okay? We're going to interpret the mean using an equal shares point. Now, so this is really important to me, guys, because this happens every year. You guys are going to be the first group that doesn't make this mistake. I believe in you. That's everybody with me? I can believe in you, right?
No.
I do. I do. If on at least 2 projects this year, I'm going to ask you to calculate the mean and interpret what it means. Okay? And when I do, if you interpret the mean as the average, it is not going to go well. I am going to be very cranky. And more importantly, you are going to be very cranky with the grade I assign that project. Is everybody good?
Yes.
The mean is the equal share point. So we're going to do a little thought experiment real quick. Imagine I had each of you go into your backpack and pull out every single writing utensil you have. Everybody with me?
Yes.
All right. So if I wanted to find the mean number of pens or pencils in your backpack, what would the first thing, you'd each have a number, right?
Then you add them all up.
All right. So what's the visual interpretation of me adding all the pens and pencils that you guys have?
An addition, long addition.
I'm seeing 2 people go like this in the back. You guys would put them all in one big pile, yes?
Okay.
Is everybody with me?
Yeah.
Okay, then that's adding them all together. And after we add them all together, we would divide by however many you guys have, right?
No. However many people put pencils in, right?
Not if we're trying to find the average of the room, right? And if you're putting all your pencils in, if everybody's putting their pencils in, and then I would divide them up amongst you guys, yes? So dividing by the number of people here,
Yes.
I would basically give you each the same amount of pens or pencils. So it would be, if each of you had the same amount of pens and pencils, that's what the mean is. Is everybody with me? You see that visual? Does that kind of help? So now start thinking about this equal share point. If I was going to apply that here, okay? If everybody had the same crossword time, equal shares. Their time would be 3.546 minutes. This could end up being a long afternoon. Everybody good? I believe this is where I shall stop because we don't have enough time to really talk about how the calculation of standard deviation goes.